Hello people, so today we're going to go through the basics of Java. Um, so let's get right into it. I'm using Apache NetBeans 12.5. You can use Eclipse or you can use something else like IntelliJ or any IDE you'd like. Okay, so let's start with things you need to memorize. Since we have a Java file that's called T1, we must know that the class name must be T1 as well. So we do public class T1. And the other thing we need to memorize is public static void main string. Okay. Now let me explain. Basically, whenever you run a Java program, it goes and looks for the main method and runs whatever is inside the main method. So that's the gist of it. Let's try and print hello world. A semicolon. And there. Okay, so we covered the basics for now, the things you need to memorize. Now let's cover variables and data types. In Java, we have quite a few data types that we call primitive types, most important of which are characters, int, double, what else, and double, and string. String isn't exactly primitive, but that's a topic for a different session. Okay, so how do we define variables in Java? We start with the type, then the variable name, then the value after the equal sign. So let's say we want to create an integer, call it x, and it should have the value of 5. Let's make a double, call it y, and it will have the value of 1.5. Okay, so integers are basically whole numbers. Doubles are numbers with decimal places. We also have long, short, float, and probably other data types, but for the purpose of this basics tutorial, we will just cover integer and double. And you will see that in 99% of the cases when you're writing a basic Java program, you wouldn't really need to use anything else. Okay, so let's make a character, call it b, and it will have the value of y as a character. Now something we don't necessarily have to do, but I'd recommend doing, is having a single quote for characters and a double quote for strings. It's not required, but in other languages it is. So anyway, let's try and print the variables we've just defined. My integer is equal to my double is equal to char is equal to, and my string is equal to s. Let's run the code, and as you can see, my integer is equal to 5. Oops, double. Okay. Okay, that's it for variables. Now let's make a new class, and in this class we will cover the basic math operations. Okay, so let's rename it. Now let's say we have an integer a that is equal to 5, an integer b that is equal to 3, and two other doubles, let's say x and y. In Java we have quite a few basic math operations that we need to know. First is the plus, minus, subtract, and multiply. We also have the plus plus, the minus minus, the plus equal, minus equal, divide equal, and multiply equal. So let's go through them one by one and see what each of them does. Let's do system.out.println and let's start with a and v. Plus, minus, and for the rest we would... Okay, let's check the normal basic ones first. So adding a and b, 5 and 3 would give us 8. Subtracting 3 from 5 would give us 2. Multiplying 3 by 5 would give us 15. And dividing 5 with 3 should, in theory, give us 1 point something. So why does it show us 1 and ignores the decimal places? The reason is that these two variables are integers, and when you divide integers, Java automatically assumes that you want the result to be an integer. So the solution to that would be to cast b to double, and let's try that out. And as you can see, so you would basically have to have one of them being a double. Let's try if it works if we had just a. Okay, that works too. So what is casting? Casting basically is transferring the data type from one data type to another. Now you can't simply just cast whatever into whatever. You can't cast a string into an integer. It's not that simple. But for numbers, usually, you would easily be able to cast a double into an integer into a double. You can also cast an integer into a character and so on, because those are just basic numerical types. So anyway, let's continue our testing with the following. So we covered these four. Let's see what the plus plus does. A plus plus, then we print the A to see the difference. So initially A was 5. Let's comment these out. And as we can see here, when we rerun the code, A was initially 5, it became 6. Simply, what A++ means is A equal A plus 1. Now, similarly, if we did A minus minus, A would just become 5, because here we changed it from 5 to 6, then we decremented it again into 5. Now, we're done with these. Let's do the plus equal and the other 4. Now, if we just comment these out as well, just to have a cleaner output. And let's see, let's say A times equal B. And let's see the output. As you can see, it's 15. We basically multiplied them and then stored the result into A. So a different way to do that is basically to say A is equal to A times B. So the output of this side would be stored in whatever variable name is on the left side. Okay. Now we would expect the other to function in a similar way. So if we try the division one, it would also give us 1, because remember they are integers. We can do double here and run the code again. But that wouldn't work, and the reason is that A is an integer, and you can't store a double into an integer. Even if you manage to do that, it would still remove whatever is after the decimal point, and it would just act normally as if whatever is after the decimal point was never there to begin with. So let's see the plus equal. It adds them together, then stores the result in A, and the minus equal would subtract them and store the result in A. Because see, we're basically just printing A, we're not printing the result directly. Okay, so I guess we're done with the basic operators. Now we have a few math functions like square root, like rounding functions, and absolute. We also have power, Okay, so each of these have a special way to be used in Java. Basically what you need to do is to use math.sqrt, then for example let's say 25, and this would basically give you the result of the square root of 25. What we're doing here is basically we're telling Java, go to the file that is called math, and from that file there is a function. We'll be covering what functions are later on, but basically just use this thing from the math file and take this input and apply it on it and give me whatever result comes back. So let's try this here. Let's do system.out.println. And as you can see, the output is 5 and it's a double. Why did we assume that it's a double? Because we have a decimal place. Now let's say math.pow 52. This function basically takes the second input and uses it as a power for the first one. So the result would be 5 to the second, which is simply 25. Okay, now to the absolute. Let's say 25 minus 99. The result should be negative, but using the absolute we remove the negative sign and we just show the positive result. Now for the rounding functions, we have 3 different functions. We have floor, ceil, and round. Floor basically rounds down towards the floor. Ceil rounds up, and round rounds normally as you would in any equation that you would solve. So let's do system.out.println math.floor 3.9999. This would be a 3. Let's do the same with ceil, but instead of 3.99 do 3.1111 or 3.00001, and this should give us a 4, as you can see here. So as I mentioned, floor rounds down, so no matter what's after the decimal point, it will push it up to the next integer. For the ceil, no matter what is after the decimal point, it would push it up towards the next integer. Floor would push it down, ceil would push it up. Now let's try the final one, which is round, and do 3.6 and 3.4. Let's just add some strings just to make things clear. And this is soft 25 minus 99. Then we have floor of 3.999, zero of 3. Now let's run the code and see the output. As you can see, around 3.6 gave us what we would normally expect from a rounding function. It rounded it up because it's closer to the next integer. And in the second case, when it was 3.4, it rounded it down because it's closer to the previous integer. Okay, so next up we have the logical operators. So T3, let's get here and get started. So one of the primitive data types that I haven't mentioned yet is the Boolean. It can be false and it can be true. So what's the deal with Booleans? What's the use of them? Why do we even have Boolean expressions in Java? We'll get to that, but for now we'll just cover the basic Boolean expressions, Boolean operators, and so on. So let's do, for example, let's first cover the operators. So we have greater than or equal, less than or equal, not equal, and equal, and I guess that's it. So when we compare two numbers, let's say 3 is greater than 3, the output that we would expect is false because these are equal. So if we try to run it, it would give us false. Now the result of this operation would be either true or false, which is a Boolean result that can be stored or used in other things like if statements and such, things that we will be discussing very shortly. But for now, just let's focus on testing out the different operators. So first we have the less than. Let's say 3 is greater than 2, then less than 2. Let's make this 3, say greater than or equal, less than or equal, and not equal, and equal. So basically the not equal would return false if both sides are equal. The equal would return false if both sides are not equal. That's the whole idea of the two equals. As we can see here, we're using a single equal to assign the value on the right to the variable on the left. But in the two equals case, we're basically comparing comparing what's on the right with what's on the left. So let's run the code and see the output. Then logically try to verify what the output is expected to be. So 3 is in fact greater than 2, so this should be true. Then here 3 is less than 2, which is absolutely not true. Then we have 3 is greater than or equal 3. It's equal to 3, so this would be true. Then we have 3 is less than or equal to, which is absolutely false. Then we have, is 3 not equal to 2? And the answer is yes, so it would give us true. Finally, 3, is it equal to 2? The answer is no, so it would return false. So true, false, true, false, true, false, and it's the same expected result. Okay, so from there we can assume that we're clear on the conditionals or the conditional operators. Now we move on to the more interesting kind, which are the and, the or, and that's pretty much it. So basically, to understand the idea of ands and ors, we need to assume that false is equal to 0 and true is equal to 1. With that being said, we can assume that the and is multiplication and the or is addition. So if we said true and false, we're basically saying 1 times 0, which would give us 0, right? So it would be false, basically. If we say false or false, we're basically doing 1, 0 plus 0, which is 0 as well. So that's false too. If we did true or false, what we're doing here is 1 plus 0, and the result is 1, so it's true. If we did true or true, if we have at least 1, 1, if either of these two is equal to 1, we would just say that the result would be 1, which is true. Now, for the and to be true, all sides should be true. So true and true would be 1 times 1, which is 1. So that would be true. To prove that what we're assuming up there is correct, we would simply just try system.out.println. Then we would do true and false, true and true. And finally, so as we explained up here, false and false would be 0 times 0, which is 0, which is false. This would also be false because we have a 0 in there. This would be true, so false, true. Then we have the OR. This would be false because 0 plus 0 is 0, which is false. 1 plus 0 is 1, so true. 1 plus 1 is 1. 1 plus 1 is 1. Although that's counterintuitive, but that's how the analogy that we're following works. So this would also be true. Let's run the code and verify our assumptions. But before that, we would need to comment these out. Okay, so as we can see here, it's false, false, true, false, true, true, false, false, true, false, true, true. So that was it for Boolean expressions. Now, as we explained here, instead of this, we can replace it with something like this, and 5 is greater than 3. It would be true, basically, because this one is true, this one is true, so the result would be true. We can also do one more thing, which is using the not operator. So basically, when we say, let's comment out this one for now. When we say system.out.println not false, this would give us true, because we're basically reversing the value. And this only works with Booleans, because we only have 2 values. If we said not true, this would result in printing false. So in this case, with that in mind, let's try to do this and add a not at the beginning. Running that would give us false, because this is true and this is a not, so this whole thing became false. When we use and, while this being true, we're doing false and true, so it would basically result in having the final answer being false. And that's basically the effect of the not operator on Boolean expressions. That was all for the boring stuff. Now we can finally move on to the more interesting things. So let's do T4. In this class we will be discussing the if statements, if, else if, and else. We will also be covering the switch case, which is quite similar to the if else. So let's say that we want to print a different welcoming message to each age group. Let's say that we will have an integer called age, and it's equal to 25, for example. If age is less than 18, we would print hello kiddo. Else if the age is greater than or equal to 18 and age is less than 30, we would say hello big guy. And if the guy is older than 30 years old, we would simply just print hello sir. So since the age is 25, it should print hello big guy, because 25 is in this range. If we change it to say 30, because we're not using the equal sign, it would print hello sir. If we changed it back into 15, let's say, it would basically print hello kiddo. That's all for the F statements. The F statements are simply just ways for you to be able to branch or select which portion of the code to run if a certain condition is applied. And just to wrap up the F statements, this is the format. And finally, we have the else. And in the else, we have code to run if none of the previous conditions are true. So that's basically it for the if else. Let's move on to a different class, and let's call it T5. And here we would have an integer z, and let's call it, or let's give it the value of 3. Now here's the deal with switch cases. Switch cases are basically quite similar to the if else, but there is one very interesting difference. So let's first write the code, then I'll be explaining the difference between them. Okay. So the thing with switch cases, other than them being written a bit differently from a syntactical perspective, the thing with switch cases is that they are based on a single variable, and they can't deal with ranges. They deal with discrete values. It can be 1, 2, 5, 1 million. It can be a character, it can be whatever, it can be a string, but it can't be a range like we did in the else if part here. Like it can't deal with any number less than this thing or any number in between these two or such. It only deals with single digits. So if we run the code here, considering that the z is equal to 3, we should see case 3 printed. Now let me remove the breaks. Case 3 and default will be printed. Break is super important when it comes to switch case. The reason being is that without a break, whenever the case related to the z is found, the code will start running and it will never stop until it finds a break. So if we had one here, oops, I can't even type. Nice. Okay. So it will simply print case 1 and case 2. If we have no breaks at all, it will print all of these, then continue running the code normally, which shouldn't happen. If you're writing the code to separate the things that will happen in different cases, then you wouldn't want to run multiple cases at once. So with the breaks being added, we can now run the code normally and see the expected result without any additions. The idea of the default is that if the case given, or if the value of z is not any of these, we would go to the default. So let's see, -1, 50, or any other number that isn't 1, 2, or 3 would give us default. Or we'll basically just run whatever is in here. That's it for the switch case. Now let's move on to the loops, which is one of the more interesting topics in this level. So let's go ahead and start with explaining the idea and the syntax of loops. Now initially we need to know that we have two types of loops. We have the for loop and we have the while loop. For the for loop, the syntax is a bit simple to understand. So we do for, then integer, then controlling, then we do for, then initial value, semicolon, condition, semicolon, change per iteration. Then from here we do whatever we want to repeat over and over and over. So, to simplify the concept, we basically use the loops to repeat a certain task, using initial value, a condition to check the value, then whenever we exit the loop, we change the value based on this section here, or this parameter here, and then we get back to the loop, we check the condition. If it's still false, we continue going into the loop. If it became true, we just, sorry, it's the other way around. If the condition was true, we go back into the loop. If the condition was false, we quit the loop. So let's take a quick example for integer I is equal to 3. Let's do I is equal to 0 first. Then I is less than 10, I plus plus, then system.out.print I with a space. So let's, before running the code, let's try to understand or try to mimic what it will be doing. So the I will start from 0 and it will check each time if the I is less than 10. Once it's done with running this stuff or whatever else is in the loop body, we call this the loop body. So once we're done running whatever is in the loop body, we increment the I by 1, and then we go again, check the condition, do whatever is in here if it's true, then increment the controlling variable again, and so on and so forth, until this condition is no longer true. So initially the I is 0, so we will be printing 0 and the space. Then the I will be 1 after finishing this stuff, because we incremented it. So it would be 1. We will go back into the loop because I is still less than 10. We'll print I, then a space, so 1 space. Then I would become 2. Check the condition, print the I, increment the I, check the condition, print the I, increment the I, and so on. So we would be basically printing the sequence of numbers from 0 to 9. When it comes to 9, when it prints 9 and we exit the loop, the I becomes 10. Then when we go back here, we check if the I is less than 10. It's not actually less than 10, it's equal to 10. So this condition becomes false and we quit the loop. Let's run the code to verify that. And as you can see here, now we need to have in mind that the I doesn't have to be called I. We can call it my loop variable, and it would still work fine. We can call it and it would still work as expected. So the name doesn't really matter, or doesn't really play a role in the functionality of the loop. Apart from that, we can also start the loop from 10, for example, and end it at 15. We can have any boundaries we want. We can also change this, so for example we would have it as plus equal to, so each time the I or the A or whatever we call the controlling variable, this variable would be basically incremented by 2. So running that, we would get 10 plus 2 is 12 plus 2 is 14. When it became 14, we added 2 again, so it became 16. 16 is not less than 15, so we stopped the loop. We can also go backwards. Let's say we want to go from 0 until a is greater than a is equal to 0. So we will keep repeating the loop from 10 all the way down to 0. We would just have to make sure that we're subtracting in this case. And let's try to mimic the output and see what it would be. I encourage you to pause the video now and try to figure out what the output would be. So I'll just start solving it now. So 10, we would go into the loop, we would print 10, then a space, subtract 2 from it, then we would go back into the loop because a is still greater than 0. We would print 8, subtract 2 again, print 6, subtract 2, 4, 2, and then we would subtract 2, check if a, which is now equal to 0, is greater than 0. This would give us false and the loop would stop. Let's run it and verify that. And as you can see there, we can also use division and multiplication as well. So it doesn't have to be plus or minus. That's the whole thing that I'm trying to clarify here. So we're done with these. We're done with 4 loops. Okay, while loops. The format of a while loop is quite a bit simpler. Basically, if the condition is true, whatever is in the loop body would be executed once and once again. It will keep running until this condition becomes false, and then it would leave the loop and continue with the rest of the code. So let's do an example on it. Let's say while, let's have an integer first, I, let's make it equal to 999. I is greater than 800. We will print the I, then we would say I minus minus. Now, there is a huge issue with while loops, which is the fact that there is no change per iteration in the syntax of the while loop. So you can easily fall for the trap of forgetting about this, or forgetting to check if this loop will ever become, or this condition will ever become false. So just always try to remember to have in the last line of code within your loop body, which is whatever in between these two curly braces. So the last line here should be changing the controlling variable in order for it to eventually in order for the condition to eventually become false. So let's run the code and see what happens. It should print the numbers, yep, from 999 down to 801. We can also do something else, and this would hopefully print from 998 down to 800. As you can see here, we can also do I minus minus, which will print from 999 down to 801. The difference between having the minus minus to the right or to the left of the variable is whether we want to subtract first or do whatever is outside. And this is quite confusing for many newcomers. So if you're confused and you're not sure which way to do it, just do it before or after the loop. Before or after printing it, I mean. So if we did I minus minus here, we would enter the loop initially with I being 999, then it would become 998, and it will start printing from there. If we had this line below here, we would start printing from 999 because no subtraction happened before the print command. So let's run this to verify and run this to verify. This would go down to 800 since it started from 998. Okay, I hope that the while loops are kinda clear. I know they are sometimes confusing for many new coders, but with examples and with problems and with practice they would eventually be quite easy to grasp. Okay, so let's go to the last two topics of this series. So let's create another class and call it T7. Let's get in here, and here's what we'll be doing here. We'll be talking about methods in Java, and we will also be covering arrays. So first let's cover the arrays, and from there we would take 3 examples on methods. What is an array? An array is basically a list of things. You can simply say type, then square brackets, name, then new type, square brackets, between the square brackets the size of the array, and that's it. Otherwise you can do type, brackets, name equal, then you put the values this way directly into the array. So let's create an integer array, call it my nums, and let's say that it has 3, 5, 6, 8, 9, 12, 18, 19, 22. So now we have an integer array that has 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. There are multiple points that I would like to cover regarding arrays. First is the fact that they can store anything. They can store integers, doubles, characters, strings, or anything in between. The second thing is the way that we access a single value in arrays is by using the name of the array, then specifying the index or the location of the variable you would like to print or to get. We need to know one thing about arrays or about counting in general in programming, which is that counting always starts from 0. So in this case we would this is what we would have. So if we want to access the value 12, we need to address it by its index or its location in the array. So let's do system.out.println. Let's say 5, which is the value 12, and let's run the code and see if it actually prints 12. And surprise, it did. To change a certain value in the array, we would simply just also use the name mynums. Let's say we want to change the 6. So we would say mynums of 2 is equal to 88. Then let's print before and after, location 2 or index 2. It was 6 before and it became 88 after changing the value. So another thing is printing the whole array. You can't exactly print an array directly. Let's comment these out for now. Okay, so you can't exactly print an array directly. If we did this, we would be in some trouble, because Java would give you the memory address where this array is stored. It wouldn't give you the contents of the array itself. To get around that, we can do a loop that starts from 0, which is the initial index, and ends at mynums dot length. Mynums is an array, and arrays have a property of having a length. So instead of counting how many elements are in there, you can directly say mynums.length and it would right away say 9 elements, because the indices are from 0 to 8. The length would be up to 9. So then we would do I++, then we would print mynums of I. Add a space and a comma, and let's run that. So as you can see here, we were able to print all the values using a loop. Okay, now let's see. After finishing functions, we will be covering multiple or multi-dimensional arrays. where we would go into a more interesting application or usage of arrays. But for now, let's just keep it simple and just from here just go right away into functions or methods. One comment is that if you're eagle-eyed, you would probably notice that I didn't use the curly braces here. And the reason being that I only have a single statement. If I had multiple statements, like it would be fine, but this thing wouldn't be part of the loop. So if we run this line wouldn't run with the loop, it would run after the loop. So without the curly braces, we only can cover a single statement. With the curly braces, if we run it now, we would have the print 3x's within the loop, and it would be also repeated 9 times or 10 times, just like the loop itself. So with that being said, I need to mention also that it's not only for loops, it's also for if statements, it's for while loops, and I guess that's it. Okay, let's now move on to methods. Let's do T8 and let's just get right into it. Now, to understand methods, we would need to simply understand that the number of lines of code that you write isn't a metric of how good your code is. So a better code would do the job in a lower number of lines or a lower line count, and it would be more efficient and more understandable. There's a dozen things to consider other than the number of lines that you basically produce. So functions allow us to write something once and keep using it over and over again without having to repeat the steps. So for example, let's say we have a double called r, and let's assume that this r is the radius of a circle. Now we want to calculate the area of the circle, and I'm not sure, but I believe that the formula is pi r square, which is math.pi times r times r and so on. Now if we forgot to call this something, so let's call it a. Let's run it. It would be fine. Let's just do system.out.println. R is R and A is A. Okay, now we can see here the results, but if we wanted to calculate the area one more time, we would have to copy the same lines, change the value to something else, change the variable names, run the code once again, and we would have the result for the second circle. One, and just like that we would have the result of the second circle. And as you can see, I forgot to change this. Sometimes other things happen in a more complicated code. So that's the reason why we use functions, to avoid doing such things. So let's see, or let's start by explaining the format of functions, or the syntax that we follow to make functions. First we do public static type name inputs So public static, the return data type, the name of the function, the inputs that the function would take. Then in the body of the function you run the code that you want to apply on the inputs, and finally you return the output, or you print it out to the user. Now public static and return type are each an interesting topic to cover by itself, but for now we will only say that in the main class, when you're making a method within the main class, the class that has the main method, you would have to make it public, static, and the rest depends on your needs. So let's make a function that calculates the area and returns a double. We would call it calculate area. The input would be a double. Let's call it rad, and let's make a double, call it area, and make it equal to math.py times whatever the user decides to give us, times itself. Or a better way to do it is using math.pal rad to the second power. From there we would be done with the calculation itself. Then we would do return area. Whatever we write here is simply a promise to the user, or to the Java IDE, that in the function somewhere I will give you a value of this type, or a variable of this type, that you can take back and send to whoever tried to use this function. So basically we created a double here, then we calculated the value that we needed to calculate, then we returned it simply, or we basically sent it back. So instead of doing this here, I would simply do calc area of R, and it will use this stuff to calculate the area using this radius. So simply the return would bring back the area value into the variable called A and would store it here. So when we run the code, note the current value. Let's run the code and see if there are any changes. No changes, but it looks quite a bit better. And we can even do this directly. Let's say 3.3, and let's do calc area 3.3. Now the upside of this is that we can do it multiple times without having to repeat the calculation each time. We just call the function and ask it to take this as our input and give us back our output. Another way to do it is to replace this return type with a void. So yeah, we replaced the double here with a void and replaced the return with a print statement. From there we can just delete these, and we can say here for rad equal rad, which is the input, the area is area, and we wouldn't even need to perform a print. So let's do directly calc area 1.5, 2.5, 3, 4, 5, 15, and as you can see, much simpler, much cleaner, and all of that was done using a single two-line function. And the more you get used to writing functions, the easier it becomes to adapt to more complex problems and to figure out simpler solutions to your projects and your problems. Anyway, that was it for the introductory Java series. We will hopefully make another one on object-oriented programming using Java, and we'll follow that up with the data structures and algorithms series. But for now, I'll see you next time, guys.